Hello students, welcome back to IT Foundation classes. I am your chemistry faculty S. Mohan. So students, we are doing your 6th class and we are doing with the basic importance of chemistry, right? And in the last class we have completed the second synopsis including exercise, question answers, and you have a my task. Are you completed that work? Students, you have to complete that my task, that is your work, you have to complete. Okay, so wherever the concept based questions what we need to explain, that we explain you, right? Okay, so today we enter into the third synopsis or the third lesson of this basic and importance of chemistry, that is air and weather. Very simple topic, easy topic. Hope you know everything about the air and weather, right? What is air? Very good. So, here what is the importance of air, students? Can you live without air? No. So, air is a very important component of the earth which making the life possible, right? So, in this chapter we are going to discuss about the air. Okay, students. So, what is air? So, students, here air is the mixture of gases. Mixture of gases. Air means, you know that you require the oxygen. I think you might already studied in the lower classes that we need oxygen for respiration. Okay, so we are taking the oxygen, we are respirating, so we are living. Does air consist of only oxygen? No. Air consists of so many other gas also, right? So, air is a mixture of gases. What are the gases present in the atmosphere? Do you know, students? Very good. So, first one is nitrogen. Okay, nitrogen. Next, oxygen. Okay. Next, carbon dioxide. Okay. And so many other gases also present in the air. So these all gases constitute means what? Combine. That makes the air. So air is a mixture of gases. Yes. Can you see the air? No, you can't see the air. Now I am here and in my room there's a lot of air is there, but can I see the air? No, I can't see the air. In your room there's the air. So can you see the air? No, you can't see the air. But friends, can you feel the air? Yes, of course, we can feel the air. How? By taking the oxygen inside, or otherwise, you see, like when you switch on a fan. Okay, when you switch on, for example, you think it's hot. Then what you do? You switch on the fan. So when fan runs, then air, okay, strikes to us. So we feel, yeah, the air, right? So we can feel the air, right? So let us discuss today about the air. Mainly our topic is about the air. So what are the properties of air? Okay, and what are the air consist of? Okay, what are the components, main important components present in the air, and what are their properties and how they can be prepared and how they are useful to us. These are all the things we are going to discuss today. Clear? Chalo students. Now we go to a topic now. So introduction to air. So already said that life on earth is not possible without the air. So without air, is it possible to live on the earth? No, because every living organism requires air, okay, to live for respiration. Without respiration, we can't live. Okay, so therefore air plays a very important, or we can say that very important is key role, okay, for the existence of a life on the earth. And we can't see the air. Yes, we cannot see the air, but we can feel the air. Yes or no? So we can feel the presence of the air around us, right? So air is not a single substance. Just how I told you that air is not a single substance. It's not like only oxygen, or it's not like only nitrogen. So air is a mixture of gases. Air is what? Mixture of gases. In that, the most important gases By volume, if you take, nitrogen occupies a more volume, okay, and oxygen little less, and other gases so less. For example, if you see in our air consists of almost 78% of nitrogen by volume, students, by volume. Okay, 78% of nitrogen is present in the atmosphere. Okay, and 21% of oxygen by volume present in the atmosphere. So 78 plus 21 add up 99, right? So 99. So more 1%. So remaining 1%, all the gases constitute, okay, to make 1% of the other part of gases. Clear to you? So in that 1%, the important gas is a carbon dioxide. What it is? A carbon dioxide. So here it is made up of many gases like oxygen, nitrogen, carbon dioxide, water vapor, so many things are there. So here, students, oxygen almost 21%, nitrogen 78%, carbon dioxide 0.3%, water vapor remaining all are present. Okay, so here oxygen, nitrogen, carbon dioxide, okay, and of course water vapor also. So they plays very important role, okay, for the human life. Not only human, in living organism. Right? How it affect, that we discuss. Okay, so now, so air is a mixture. We said that air is a mixture. Mixture means what? Combination of many substances is called a mixture. So air is a mixture. Now, of course, air also consists of dust and smoke. Yes, this you know. Okay, you know about the air pollution. So, yeah, air pollution is what? Unwanted materials which are present in the air that causes some harmful effects on the life of organisms. So, that is called air pollution. So, this air pollution is due to some unwanted particles also present like smoke, dust also present in the air. Right. So, now let's come to the atmosphere. What is the atmosphere? Atmosphere is nothing but the earth is surrounded by the mixture of air, right? So, for example, if you take this as earth, okay, earth, this is earth, and earth is surrounded by the mixture of gases. That mixture of gases means air. So, this all air is present around the earth, and this presence of air around surrounding the earth is called atmosphere. What it is called? Atmosphere. That's called atmosphere. Clear, students? Any doubt about the air? Okay. Now, let us see the properties of air. What are the properties of air? The first property we can say that air has a weight. Air has a weight. Do you think that air has a weight? Yes, air has a weight. So, how do you feel that? Do you feel that see, we are in the earth, so now a lot of air is there around us. So, above our head also there is a lot of air is there. Yes or no? Does it exerts, okay, any like pressure due to weight on our head? No, we don't feel that air has a weight, but air has a weight. How can you prove that air has a weight? So, here some small experiment is given, right? So, students, here you take two balloons. You take two balloons, okay, and blow the air into the balloons. Equal quantity of air blow in two balloons. Now, these two balloons tie to the two ends of the stick or scale. The scale is better. So, and here a stick or scale you can take here. So, here the balloon, okay. So, here one balloon and here another balloon, alright. So, two balloons are filled with the air and they tied at the two ends of the scale, or one stick also you can take, right. Now, take one thread and tie at exactly center of the stick or scale. Now, hold it, okay, you know the balance, okay, right, like this. So, then what happens? Both will be balanced, yes or no? So, see, both are in balance, okay. Now, take one pin and just what do you do? Just pin the red balloon. Then what happens? All the gas will be removed from that one. Whenever the gas is removed, then what happens? Now this stick, you can see it is like horizontal. Now it becomes like slope, like, okay, slant. Why? Because here in this balloon air is there. So this air is exert, means it has a weight. So due to this weight, then what happens? It comes down, right? So this goes up. So this is an experiment to show that air has a weight. Yes. So I can do this experiment at home, students. See here, students. Simple experiment which you can able to do. Such type of experiments you have to do it. Okay. So here, not just science is not just listening, right? So here experimentally you have to gain your knowledge, right? So that is a science. So students, that improves your skills of observation and doing the experiments. Okay. So right. So this experiment shows that air has a weight. Okay. Now then come to the second property. Air exerts a pressure. This is important, students. Air exerts a pressure. What is mean the pressure? Do you know what is mean the pressure? So pressure is equal to, if you say scientifically, pressure is equal to force by area. What is the formula of pressure? So pressure is equal to force by area. Okay. What is force? Push or pull. Okay. If you want to close the door, then what you do? You just push the door. So you are pushing the door means what? You are applying some force on the door. So the door is getting closed. So you are pushing the door means what? You are making the door to move away from you, right? Now if you want to open the door, then what you do? Then here also you apply the force, but you pull it. Pull it means what? You are bringing the door to yourself, right? So door cannot move by itself, either during closing or opening. So you are applying the force. Yes or no? You are applying the force to pull or push. So this is called force. So force is push or pull, students. Up to your 6th class, 7th class, you learn like a force is a push or pull. But if you go to the higher classes, so we have a formula for force also. The force is nothing but a product of mass into acceleration, that we discuss in the higher classes. But as of now, force means what? Push or pull. Clear? So that is a force. Now next is what? Per unit area. Area means what? See, for example, okay, here I have some book. Okay, so here I am having some book, right? So here I am applying the force. Applying the force means what? See, like this. Okay, I am pressing down. For example, I am pressing down. Okay, so I am applying the force. Then what happens? It is going down. Yes or no? So how much force you are applying on a particular area? Area means what? For example, this book is there. Okay, this is one book is there. So this book, what is the area of this surface? So I think in the mathematics you might have studied area. Do you know? Okay, area is nothing but this is the length and this is the breadth. The surface is called area. So the surface, how will get how much area? So we multiply this length and breadth. So that will get the area. So force per area, force per unit area is called as a pressure. Understand of pressure? So pressure is nothing but a force per area. And here air exerts a pressure. Air exerts a pressure. Where it exerts a pressure? It exerts everywhere, students. Very important point here. Air exerts a pressure. Where it exerts a pressure? Question is where it exerts a pressure. It exerts everywhere. Air exerts a pressure downwards. Air exerts a pressure upwards. Air exerts a pressure sidewards. Everywhere the air exerts a pressure. How? We discuss now one by one. Next, here this is also very important point, that air occupies a space. Yes. Now for example, this room is there. This is a very big hall, very big classroom, right? Now in this classroom, air is there. Every corner of you go, you can find the air. Every corner of this room, you can find the air. Not only in my room, even in your room also, you can go to every corner of your room, you can find the air. So meaning is what? Air is occupying the space. Clear to you? So air occupies the space. Now simple example, you can see the balloon. So if you blow the air, so air is occupying the space of the balloon. Yes or no? So air occupies the space. So what are the three important properties? First one is what? Air has a weight. What's the second one? Air exerts a pressure. And what's the third one? Air occupies a space. Clear? Any doubt? Sure. Now let's go to the next one. Composition of air. This already discussed now. The important constituents of air are oxygen, nitrogen, carbon dioxide and water vapor. So these are the important components that are present in the air, right? And air contains about 78% of nitrogen. So since students already have written here, 78% of nitrogen, 21% of oxygen. See, 21% of oxygen by volume. By volume. Volume means, the space occupied by any object is measured in terms of volume. Okay. So the space occupied by any substance is known as a volume. So here 21 plus 78. So this comes to how much? 21 plus 78 is equal to 99. So remaining 1% consists of all other gases. The remaining 1% consists of inert gases, carbon dioxide, water vapor and other gases. Is this clear, students? So that is about the composition of air. Okay. Chalo, I'll give 1 minute time to you. So revise this once, go through the slide. If you have any doubt, then you can ask me the doubt. Clear? Check once. Okay, students. Now, next is oxygen. So here, if you see the oxygen, just now we discussed that air is a mixture of gases, right? And in all the components like nitrogen, oxygen, carbon dioxide, among all these components, oxygen is the only component which helps in burning. Okay. So oxygen, the component of air which helps in burning is oxygen. Okay. So with the help of oxygen, only the burning will be taking place. Right. Now, the name to this oxygen is given by the scientist called Lavoisier. So Lavoisier, Antoine Lavoisier named the gas which helps is this oxygen. Right. From where this oxygen comes? Actually, naturally oxygen is present in the atmosphere, but still, I think that plant releases oxygen. Right. So nowadays, government is canvassing and saying that to promoting to plant the trees, right? Why? Because here the level of oxygen will be increases, carbon dioxide level will be decreases. Plants absorb the carbon dioxide, students, and they releases the oxygen, right? So here green plants releases oxygen and by the process called photosynthesis. I hope that you know about the photosynthesis. So plants prepare their food okay, in presence of sunlight, by taking carbon dioxide and water, okay, with the help of chlorophyll in the form of carbohydrates and releases the oxygen. So this reaction is called photosynthesis, right? So plants prepare their food by the process called photosynthesis. Here, what's the meaning of photosynthesis? Students, here photo means light. Photo means what? Light. Synthesis means what? Preparation. So here plants prepare their food with the help of sunlight. So hence this reaction is called photosynthesis. So you can see here photo means what? Light. Synthesis means what? To prepare. So by photosynthesis, green plants prepare their food. How? See, by using the carbon dioxide and water. I think you might have known the reaction. 6 CO2, there is a carbon dioxide. 6 H2O, there is a water. That gives C6H12O6, that's a carbohydrates, plus 6 O2, right? So this is a reaction, and this reaction takes place in presence of sunlight with the help of chlorophyll, right? So this is a chlorophyll. This reaction is called photosynthesis. So during the photosynthesis, we can get the oxygen, right, students? And where the oxygen is useful? Oxygen is present in air, and it's useful for us in respiration. Respiration is what? Taking the air. Okay. So respiration, you know that we can take the oxygen and we release the carbon dioxide gas, right? So oxygen present in water is dissolved state which is used by the aquatic animals. So you can see here, these are some aquatic animals. So like fishes, these all they can live under the water, but they also require the oxygen, right? So here they require the oxygen, they utilize this oxygen, okay, from the dissolved water. So in the water, the certain amount of oxygen will be dissolved. So this is utilized by these animals, okay, aquatic animals. So that's all, students, that is about the oxygen. Must go through the oxygen. Okay, students. Now let's go to the next topic, that is about preparation. How can we prepare? Acha, so you know that oxygen is available in the nature. Okay, can we prepare the oxygen artificially? Means yes, we can prepare the oxygen artificially in the laboratories. Okay, how can we prepare? There are so many methods out there, but here they mentioned about the preparation of oxygen from potassium chlorate. From where? Potassium chlorate. So see, students, here potassium chlorate formula is KClO3. Okay, on heating potassium chlorate in presence of manganese dioxide, MnO2. MnO2 is what? Manganese dioxide. In presence of manganese dioxide releases the oxygen. Okay, so reaction will be like this, students. Here potassium chloride to KClO3 for balancing we are writing here, and here MnO2 acts as a catalyst, students. Here it acts as a catalyst. So then what happens? It splits into 2 KCl plus 3 O2. Okay, so this is chemical reaction or equation involved in the preparation of oxygen from potassium chlorate. So here you can see the potassium chlorate is taken in the test tube. Can you see here? This is called a test tube. Already we discussed some important material that we use in the laboratory, right? So here test tube is one of the most important laboratory equipment which we regularly use, right? So here potassium chlorate, okay, is taken in the test tube along with a certain amount of manganese dioxide. So manganese dioxide is what? It is a material which acts like a catalyst. Do you know what is catalyst? Catalyst means what? Which promotes the rate of reaction, okay, which do not involve in the chemical reaction, but it promotes the chemical reaction. Means it helps in quickens the yield of oxygen. So it helps in complete the reaction quickly. Okay, so now here what happens? On heating, this potassium chlorate decomposes. Decomposes means what? Splits into potassium chloride and oxygen. And being oxygen is a gas, this gas comes out through this delivery tube. This is what? Delivery tube, and it enters into the gas collecting jar. What it is? This is called a gas collecting jar. So here gas is collected in this jar, so due to the downward displacement of water. So we first we take the water. So then as the oxygen enters into the gas collecting jar, the water level will be decreases and oxygen is collected at the here at the top. Is this clear? So like this, all the water will be displaced and oxygen is collected there. Now, so in this way we can collect the oxygen. After collecting the oxygen, if you want to test it, okay, so whether the collected gas is oxygen or not, how can you test it? Very simple, by bringing the burning splinter. When you bring the burning splinter, it burns with the okay bright flame, right? So here you see, so that's what. So here's how do you test the oxygen. So the burning splinter burns brightly in presence of oxygen. So when you bring the burning splinter near the okay near the this gas collecting jar where the oxygen is present, then what happens? It burns. Clear, students? So that is about this one, right? And what is a collected jar? You know that we cannot see because oxygen is a colorless gas, odorless and tasteless, but it is slightly soluble in water, okay, and it is slightly heavier than air. Clear, students? Okay, so that's all, students. So that is about the oxygen preparation. So how we prepare the oxygen in the laboratory? So first is the oxygen is our naturally available, but even we can also prepare in the laboratories also. How? By heating the potassium chloride in presence of manganese dioxide. Yeah, manganese dioxide acts as a catalyst. Okay, so on heating, potassium chloride decomposes and splits into the potassium chloride and oxygen, right? And the gas collected by the downward displacement of water, and this gas is a colorless, odorless and tasteless gas, student. Okay, but it is slightly heavier than air and it dissolves in water. So this oxygen is dissolved in water. By utilizing that, the aquatic animals can live. Okay, and how do you test the oxygen? Oxygen can be tested by bringing the burning splinter near the oxygen, so it burns more brightly. Yes, students, once go through this slide. Okay, students, now let's go to the next one, that is about the nitrogen. So nitrogen is also one of the most important component of the air, already we discussed, and nitrogen is also present almost 79%. Okay, when you compare with oxygen, it's 4 times more, okay, in the atmosphere, right? But this gas is not combustible. Combustible means what? Which do not helps in burning. Okay, like just now I told you that oxygen helps in burning, but nitrogen does not helps in burning. So here nitrogen does not support the burning. It does not support the burning. Okay, and the ratio also said that nitrogen oxygen ratio is 4:1. Nitrogen is almost 79% in the atmosphere, where the oxygen is 21%. If you calculate the ratio, that comes to approximately nitrogen oxygen ratio is 4:1. Okay, and the Chaptal was a scientist who gave the name, okay, to this gas as a nitrogen, as it does not support the burning and it's not support the respiration. Means what? For living organisms. Okay, so here you can see does not support the burning and respiration. Is this clear, students? So here, then if it is not support the burning, then it is not support for respiration, then what is the use of nitrogen? Students, nitrogen has a very important role, okay, in the life of plants and animals. Okay, so here plants requires the nitrogen. Nitrogen is one of the most important nutrient, okay, to the plants. But here some plants cannot take the nitrogen directly from the atmosphere, but here a type of bacteria will be present. This bacteria takes the atmospheric nitrogen and it convert into soluble salts of nitrogen, so by which the plants can absorb the nitrogen. So this process is called nitrogen fixation. What is called nitrogen fixation. So nitrogen, one of the most important nutrient even for animals also. Okay, so since here students, here the plants, animal bodies and their excreta contains nitrogen in the form of its salts. See here, beans, peas, groundnuts, so are leguminous plants, depends on bacteria present in their root nodules for nitrogen. So see students, here these plants cannot absorb the nitrogen directly. A lot of nitrogen in the atmosphere, but still that nitrogen cannot be absorbed directly by these plants. But nitrogen is essential to the plants because it is one of the most important nutrients to the plants, right? Then how the nitrogen taken by these plants? So here there is one kind of bacteria is present in the roots of these plants. Okay, so this bacteria will convert this nitrogen into soluble salts. Okay, and these soluble salts are absorbed by the plants through the nodules and okay, they fulfill their requirement. This process is called nitrogen fixation. Okay, so this bacteria converts atmospheric nitrogen into nitrogenous salts and this process is called nitrogen fixation. What it is called? Nitrogen fixation. So nitrogen is one of the most important component, right? Now then come to the properties of nitrogen. So properties of nitrogen is also seen. Nitrogen, you know that most of the atmosphere consists of nitrogen, but can you see the nitrogen? I can't see. So the meaning is what? Nitrogen is colorless, right? And here 79% of nitrogen is present in the atmosphere. Can you smell? No, there's no smell. So no odor and no color. So colorless, odorless gas, which is slightly soluble in water, very lightly soluble in water, and it does not support the burning. So what the burning splinter is put off in the presence of nitrogen. If you collect the nitrogen in one gas collecting jar and if you bring the burning splinter there, then what happens? It put off. Okay, it will not burn brightly. Where if you bring near the oxygen, oxygen burns brightly. The meaning is what? Oxygen supports the burning, but nitrogen does not support the burning. Okay, so this about the nitrogen. So let's go through this nitrogen, students. Okay. Oh, now third component. Okay, so important components, one is nitrogen, oxygen is done. Now the third component is what? Carbon dioxide. So what's the carbon dioxide? Just now we discussed about the carbon dioxide. Plants absorb the carbon dioxide and with the help and plants absorb the carbon dioxide and water by the process called photosynthesis. This releases the oxygen, right? So plants absorb the carbon dioxide. So if you come to the properties of the carbon dioxide is also colorless gas, students. Okay, the carbon dioxide is also colorless, so we can't say, but it has a smell. So it has a odor, and it is approximately 1.5 times heavier than the air. How much? 1.5 times heavier than the air. Means what? Heavier. Okay, heavier than the air. So it is a colorless, odorless. So here, sorry, it has less odor. Small odor is there, and 1.5 times heavier than the air. Okay, and carbon dioxide released during the respiration. Yes, you know that already we discussed. During the respiration we inhale oxygen and we exhale the carbon dioxide. So carbon dioxide is released by the human beings, right? And when fuels burn, fuel means what? Like wood, petrol, coal, diesel, these all when they burn, they releases the smoke. You know, that smoke consists of carbon dioxide. That smoke consists of what? Carbon dioxide. So fuel, wood, petrol, kerosene, etc. on burning releases the carbon dioxide. Clear, students? Now, how can we test the carbon dioxide gas? How can we test the carbon dioxide gas? So students, here carbon dioxide gas can be tested by passing this gas into the lime water. So when you pass this carbon dioxide gas into the lime water, it turns into milky white. It turns into milky white. Okay, so lime water means what? Lime water means what? Calcium hydroxide, CaOH taken twice. This is called calcium hydroxide. Okay, lime water. Lime water formula is calcium hydroxide. Okay, so we take the lime water, this calcium hydroxide solution. Okay, now in this if we pass the carbon dioxide. Okay, carbon dioxide formula you know, CO2. Carbon means C, symbol of carbon is C. Dioxide, di means what? 2. Oxide means what? Oxygens. 1 carbon, 2 oxygens. So that's called carbon dioxide. So when we pass the carbon dioxide, then what happens? It forms CaCO3 plus H2O. Okay, so this is called a calcium carbonate. So due to the formation of calcium carbonate, this lime water, okay, this lime water turns into milky white. Okay, turns into milky white. Is there? So see here, lime water turns milky in presence of a carbon dioxide. Clear, students? So in this way, we can test the carbon dioxide. Okay. Now you know that the atmosphere consists of a number of gases, like mixture of gases. Now the question rises that, sir, can we separate these gases? Okay, so so many amount of gases over there. Can we separate these gases? Means what? By normal method, students, we cannot separate the gases. Okay, but there is a method to separate the gases. So that is called fractional distillation. What is called? Fractional distillation. By the process called fractional distillation, we can separate the gases, but it is a little complex process. You will be learning in the okay higher classes, right? So how it will be fractional distillation? How it will be separated? So very simple. The first term, all the air will be collected, okay, and the temperature is reduced under pressure. So then what happens? When the temperature is reduced, they will be converted into the liquids. They will be converted into the liquids. Are you surprising? Can we convert the oxygen, nitrogen into liquids? Yes, students, we can convert them. Okay, we can convert the gases into liquids. Still, if you bring low temperature, then it may be converted into solids also. Okay, so but it requires very low temperature. Okay, in the minus degrees. So first, here what happens is this gas means air is collected, and this air is under the high pressure it is cooled, so they will be converted into the liquids, and after that okay, they will be separated by using the fractional distillation method. So this we discuss in the higher classes. Okay, because now we are in the 6th class, it is not okay topic to understand you, right? Okay, so see here this given slightly, just let us see. The separation of mixture of liquids into constituents by changing the temperature of different is called fractional distillation. In this method, see here, air is liquefied, and then various components of liquefied gas or liquefied air are separated. So this method is called the fractional distillation. So there is a possibility, so it is possible to separate the component of air like oxygen, nitrogen, carbon dioxide, we can separate it. Now then photosynthesis, already we discussed about the photosynthesis. So photosynthesis, so this is a plant, and plant will have the chlorophyll. What is there in the plant leaf? There is a chlorophyll. Okay, so this chlorophyll observe the sunlight, and by taking the carbon dioxide and water, and observing the sunlight, it prepares its food in the form of carbohydrates and oxygen. Okay, so carbohydrates, it acts as a food for it, so it intake the carbohydrate and releases the oxygen. Okay, so we require the oxygen, so the plants are giving us oxygen. Okay, so students, it's a very important to protect our earth, to protect ourselves. Then we need a fresh air, fresh oxygen. For this, plants are required, trees are required. So protect the plant, and as much as possible, it's better to plant a tree. Okay, so at least every year one tree you have to plant. Okay, plant one small, clear, and take care of that one. Not just planting the tree and you are leaving it. No, okay, you have to plant them. Is this clear? And you have to protect that. Okay, so that's a responsibility. Okay, so see this slide. Okay, students, finished. Okay, now let's come to the new topic, that is air pressure. Air pressure. Very simple. What is the air pressure? The pressure exerted by the air. The pressure exerted by the air is called the air pressure. Now the question is that, sir, does air exert the pressure? Yes, of course. Any substance, anything which has a weight or which has a mass exerts the pressure. And already we discussed like in the balloon experiment, right? Air has a weight, so air exerts the pressure. So the pressure exerted by the air is called as a air pressure. Okay, so air pressure. Any substance which has a weight, see, very important students, any substance which has a weight exerts pressure. So air has a weight, so this also exerts the pressure, right? So the air exerts the pressure. This pressure is called as a air pressure. Acha. So what is mean by the pressure? What is mean by the pressure? So pressure means what? The force per unit area. Okay. So see students, in the science we have some formulas also. Okay. So here pressure is equal to, okay, pressure is equal to force by area. Force by area. Okay, is this clear? So force by area. So when we apply the force on a particular area of the object, then that is called the, okay, pressure. So air exerts the pressure. That pressure is called the, okay, air pressure. Now where this air exerts the pressure? Students, air exerts the pressure in all directions. Very important point this also. Okay, Air, sir, air exerts the pressure only downwards means no. Air exerts the pressure in all direction. Air pressure exerts the pressure downwards. Air exerts the pressure upwards, and air exerts the pressure from sidewards also. From all the sides, okay, the air exerts the pressure, right? So how can you say that air exerts the pressure from downwards also? Very simple. So here there is like one experiment. Okay, that experiment is what? You take one glass tumbler. What do you take? Take one glass tumbler. Okay, so this is a glass tumbler. Okay, now in this glass tumbler, fill with the water. Fill with the water. So I am taking this one. So fill with the water like this. Clear? So filling with the water. And then what you do? Take one stiff paper. Take one stiff paper. Okay. For example, now I don't have the water tumbler here. For example, I am taking one. Okay. This example, it's not experiment. So here I don't have the glass tumbler. I don't have the tumbler. So that's what I'm taking. For example, explaining you. Imagine this is a tumbler. Okay. And in this, take certain amount of water. And then, okay, take one stiff paper. Okay, take one stiff paper, okay, and then put over the open end of the tumbler and fix it like this. Apply the pressure, and then invert this glass. Okay, invert this glass. Are you following what I'm telling? Okay, so here, students, you are filling the water till here. Then we take one stiff paper or cardboard like this. Okay, place on this one and hold it tightly and invert the glass. After inverting, slowly remove your hand. Okay, so then what should happen actually? The water should fall, right? Because you are inverting and just we kept the paper only. Okay, so what should happen? The water should fall. Yes, but water does not fall here. Water does not fall. Why? Because from the bottom, air is exerting the pressure. So due to that pressure, the water will not fall down. Okay. This experiment you can do at home, students. Very simple experiment. Just take the glass and take certain amount of water and take one stiff paper like cardboard like one and just put it over it. Okay, over the front and little press it. Okay, little press it and invert it and slowly you remove your hand. So now water will not fall. So actually it should fall because water has a weight, so it should fall, but it do not fall because of air pressure. Okay, so this is the experiment of air exerts the pressure. Okay, so from where? Upward pressure. This is called upward pressure, right? Now does air exert the downward pressure? Yes, this also can be. How we can explain? So they are also very simple. So take the same glass tumbler, like this glass tumbler you take. Okay, so take the glass tumbler. Okay, and now take one small cork, you know, which is made up of like rubber, which do not sink in the water. Okay, rubber material do not sink, no. So take some cork. So here I am placing some cork. This is a cork. So actually what happens, this cork will be floating on the water. What's happening? It floats on the water, correct? So now what I do, otherwise I will take, what we do is, instead of glass, we take one, okay. So see here, you take one like this vessel, okay, a big vessel you take. This is a big vessel, and in this you take the water. This is a water, all right. Now you place one cork here. So this is a cork, okay. This is a cork, right. Now this cork floats on the water, right. Now what you do? Take the glass tumbler, empty glass tumbler. Take the glass tumbler and invert, okay, means ulta. So invert over this cork, okay. Invert over this cork, okay. Now you just apply the force on the glass, okay, on this tumbler. Then what you'll observe, this cork will move down. Now the cork will move down, means it's going into the water. Actually it floats, but as you are applying the pressure on the tumbler, not on the cork. On the tumbler we are applying the force. So then what happens? Cork will be sink, means goes into the water. Okay, why? Because in the tumbler air is there. What is there here? Air. So this air is exerting the pressure. Air is exerting the pressure, okay, over that cork. So due to that, cork will sink, dip in the water. Okay, so this experiment shows that air exerts the pressure downward also. So here air exerts the pressure upward and air exerts the pressure even in downwards also. So you have letter. So you observe that air in the glass exerts some downward pressure and pushes the cork down. Okay, so this is a statement to check that pressure, air has a pressure and it exerts the pressure downwards also. Right, friends? Let's go through this slide. Okay, so now let's go to the this one. Now air exerts the pressure in sideways also. Yeah, just now I told you that air exerts pressure from all the sides. Okay, how can you say that air exerts the pressure from sideways also? Very simple, students. So what you do, for example, if you have a tin bottle, okay, tin bottle, you know, a Coke bottle, tins available. Okay, you take that tin bottle or something. Okay, and you heat that tin bottle. You just heat the tin bottle. You know that if you take the empty tin bottle, in that air will be present. Everywhere air is present. So on heating, this air get expands. On heating, what happens? Air get expands. That expanded air will move, okay, away from the tin bottle. Okay, it will move away from the tin bottle. Right? Then when the air is removed totally, okay, then immediately what you do? Okay, close the bottle with the lid and put in the water. Even if you don't put in the water also, no problem. If you put outside, then what happens? This air exerts the pressure on the tin and the tin get crushed. Tin get water crushed. Because on heating water, what happened? Yeah, the total air is gone away from the tin. Okay, now tin became like empty, almost vacuum. Okay, the meaning is what? Inside there is no pressure. Inside there is no pressure. Now, but outside lot of pressure is there. So this outside pressure crush the tin bottle. Crush the tin bottle. And even it get squeezed also. Even it get squeezed. Okay, the meaning is what? From all the sides, the pressure, okay, acting on the tin. And from where this pressure has come? From the air, atmosphere. So this atmospheric pressure exerts on the tin and that crush the tin and squeeze it. Okay, this is also simple experiment. We can do it at home. Okay, so that's all, students, about the so here say take a tin container made up of a thin metal sheet and heat the tin with the spirit lamp and push out the air. Okay, and then close the lid of the tin and you observe the sides of the tin. Okay, the sides of the tins, we say that get crushed. Okay, so and that get twisted also. Right, students? So okay, so with this we stop today. So with this we completed what? Air pressure. Up to air pressure we are completed. Now the next topic is about the air pollution is there, that we continue in the next class. Air pollution and layers of atmosphere is also there, that we continue in the next class. Okay, so with this we stop the class. Okay, students, bye, take care.